Okay, so we're finishing 3.2, which is dividing polynomial. And we'll finish also 3.3 today. Yeah, because 3.3 is not that much. All right. So let's start. So 3.3, 3.2. Okay, so this is what we, oh, is this the one that we did? Did I lose it again? Oh yeah, this is dividing polynomials. Okay. All right, so now part E, so did I, B, okay. So part C is finding polynomials with special zeros, so given zero.
You said yesterday you were going to go back to that factor now.
The factor theorem? Oh,
we did the remainder theorem and then you skipped it.
Oh, okay. So if k is a zero of f of x, if and only if x minus k is a factor of f of x. So the proof is really simple. It's actually only 2 lines. So let me erase this. All right. So how do you write the f of x again? Oh, f of x is what? X minus k and times. What did I use? Is it q of x? Yeah, I put here q of x plus r. Right? Okay. So if k is a 0, what does it mean? So if k is a 0, then what do I mean by that? So x minus k is the remainder is a 0. So if k is a 0, right? Then the remainder is a 0. Okay. So I could put f of k is equal to well, if the remainder is 0, then f of x is equal to x minus k times q of x, right? Plus 0. So if I could write f of x in terms of x minus k times q of x, then it means k is a factor. So if I could write it like this, which means x minus k is a factor of f of x. So this is what I need to write down, yeah? So if k is a 0, and remember, it means the remainder is a 0 by the remainder theorem, isn't it? So if this is a 0, then I could write f of x in terms of x minus k times q of x plus 0. So this is plus 0. So you don't need to write plus 0. So if you could write f of x equals to x minus k times q of x, it means x minus k is a factor of f of x, right? So if I could write, for example, 6 is equal to 2 times 3, what can I say about 2 and 3? 2 is a factor of 6. 3 is a factor of 6. So if I could write f of x is equal to x minus k times q of x, what can I say about x minus k? X minus k is a factor of f of x. Also, q of x is a factor of f of x. So that's what it is. Yeah? All right. Are we okay so far? So, but anyhow, if you think the proof is almost the same as the other proof, you don't have to worry about it. Did I write down the 4 equivalent statements before? Did I write down the 4 equivalent statements? No, I didn't? Okay, so I should write down the 4 equivalent statements. Oh, you know, I'm teaching 2 different maths to 60, so I forgot which one is which. Yes. So for equivalent statements, I never write this in your class before. Maybe in 3.1. So I say K is a 0 of f of x. And then x minus k is a factor of f of x. So these are all equivalent. Two more. 3. K comma 0 is an x-intercept. And then k, what was the last one? Hold on. X equals to k is a solution of f of x equals to 0. I've never written this in this course. No? Yes, no? Yes, I did, right? Yeah, okay. Okay, so I didn't remember wrong. Okay, yes, I wrote this before. Yeah? So if k is 0, x minus k is a factor of f of x. Okay. Now, what we want to do next, so if you just remember this is good. Yeah. What we want to do next is finding polynomials given the zeros. So C, finding polynomial given specific zeros. All right. So, for example, find the polynomial of degree 4, or find a polynomial, it's not the only one, of degree 4 with zeros, -2, 0, 2, and 4. So what would you do? Yes, Josh. Right. Right. Yes, that's right. So did anybody hear what Josh said? So if the zeros are -2, what is the factor related to -2? X minus k. So these are all your k's. So x minus -2. So what is x minus -2? X plus 2, yes. And then x minus 0, right? Or you could just say x, of course. And then x minus 2 and x minus 4. Yeah. So it is always x minus whatever 0 it is that we have. Okay. So now we just have to multiply these out. So let's arrange this. X times x plus 2, x minus 2, x minus 4. So which one's easier to do? This one? X plus 2, x minus 2? Okay, so put the x here. What is x plus 2, x minus 2? This is a special product. Yes, so this is, you remember a plus b times a minus b. The middle terms cancel. So we only have first and last. So first is x squared and last is -4. Okay, good. So multiply them all. So let's do x squared minus 4 times x minus 4. So what is this? Yes, x cubed minus 4x squared minus 4x plus 16. Okay, and then we just have to multiply by x. So this is x to the 4 minus 4x cubed minus 4x squared plus 16x. Yeah. Okay. So these are all the zeros or the k. So this is x minus k. So each one of these is x minus k. All right. Now I'm done with 3.2. Can I clarify anything? No? Are we good? Okay. So the next one is we're going to find the real zeros. Yeah? All right. Let's do the next one. Next, ready? Yeah. So let me save this. File, save as. Dividing polynomials. 3.2. All right. Okay, so save as dividing polynomials. Okay, good. So dividing polynomials. All right, so now let's do a new page. So 3.3. Oh, let me stop this first so I could have the title. Sorry. So we're done with 3.2 and we will start with 3.3, which is the real zeros of polynomials. Okay. I think we might finish today also. So let's start. Rational zero theorem, the card rule, factor completely. Yes, I think so. Let's share the desktop. So what's homework going to be due on Sunday? 3.2 and 3.3, yes. I don't remember if I put the due dates or not, but probably I did, probably I didn't. Okay. So 3.3 is real zeros of polynomials. Should we have a quiz on Monday? Or do you want it online? So let me think about it, okay? So if I put a quiz online, it will be due on Wednesday, all right? But you could probably do it on the weekend. Yeah, okay. So A is rational zeros theorem. So rational zeros theorem. Yeah, we do. We don't celebrate Columbus Day, but we celebrate Cesar Chavez. So a lot of people don't celebrate Cesar Chavez, but they celebrate Columbus Day. So if the polynomial, actually it's almost Jewish holiday, right? Is anyone Jewish? No. Yom Kippur. It passed. The Rosh Hashanah passed. The New Year passed, but there is October 11. They said there is a Yom Kippur. You have to fast or not do nothing for like 25 hours or 24 hours. That's what I heard. You can't drink, you can't eat, you can. That's what my friend told me. I don't know. Yeah. Yeah, I will probably just stay in bed, right? And then think, right? Okay. And then meditate, like that. No, I'm not Jewish, so I don't celebrate those. But I'm just saying that, yeah. So it's interesting. So it's one day for like thinking about yourself, things like that. Okay. So if the polynomial p of x is equals to an x to the n plus an minus 1 x to the n minus 1 plus blah 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 plus a1x plus a0 has integer coefficients, then the possible rational zeros of p of x have the form p over q, so plus minus p over q, so both positive and negative, p over q. So what is p? Where p is the factor of the constant. So P is the factor of the constant. Constant is what? A naught, right? And Q is the factor of the leading term, or leading coefficient. The factor of the leading coefficient. Q, AN. Actually, thinking about religion, every religion is good, right? As long as you don't, as long as you use brain. I mean, you don't kill people because of religion. I mean, every religion teaches you to treat other people well, isn't it? Yeah. And so if you kill because of your religion, then that is something else. Yeah. So I don't know. That's my philosophy. So there's nothing wrong with Hindu, Buddha, Muslim, Christian. They actually mean good. It's just the follower interpret them differently. You know. You don't have religion? I don't know. I feel that it's just me, but I feel that if there is no God, it's really hard for me to hold on to something. I don't know. It's just me. Yeah. All right. So anyway, so for each polynomial, this is what I want to do. So what does it say about the P and Q? What about the rational zeros? What is P? All the factors of the constant. And what is Q? All the factors of the leading coefficient. Yeah. So let's talk about find rational zeros. So for example, so find the possible rational zeros. Why are zeros important anyway? Well, you have to solve and you have to graph. That's why they're important. Important in graphing, important in solving equations. So P of x is equal to x cubed plus, oh no, sorry, minus 7x squared plus 14x minus 8. So what are the possible rational zeros? What are the candidates for rational zeros? I'm not saying that all of them are the rational zeros, but they're the candidates for the rational zeros. Yeah. So answer, plus or minus P over Q. So what is your P here? 8. So I'm looking at 8. And what are all the factors of 8? 1. What else? 2, 4, and 8. Yeah. And what is your Q? 1. Well, it is the leading coefficient. There is no coefficient. So what is the coefficient if there is none? 1. So it's just going to be, what are all the factors of 1? It's just 1. So all the possible rational zeros are plus or minus 1, 2, 4, and 8. Yeah. So if I have a rational zeros, then it's going to be one of this list or 2 from this list. So later on we will find all the real zeros. Yeah, but these are the candidates. Are they all rational zeros of the function? No, but if you have 1, then it's going to be either plus or minus 1, or plus or minus 2, or plus or minus 4, or plus or minus 8. Yeah. Okay, so we'll do the thing later. What about if I have P of x is equal to 4x cubed plus 4x squared minus x minus 1. So I want you to find the candidates for rational zeros. I'm not saying that all of them are the rational zeros, but they're the candidates. So can you give me a list then? So P, what am I looking at? 1? Okay. So 1, what are all the factors of 1? Just 1. All right, good. Now Q, what am I looking at? 4. So what are all the factors of 4? 1, 2, and 4. So what are my possible rational zeros? Maybe I should write it like this instead of plus or minus 3 over 2. So I'm going to write down like this. So possible rational zeros or candidates for rational zeros. And then I'm going to list it. So here, possible rational zeros is plus or minus what? 1, what else? Half and 1/4. Yeah. Okay, easy. So the next step, we will take it further. We will find the actual zeros. So when you're done, and I'm going to read it, to write it. Okay, I better sit down here. This is too low, so I have to bend. All right. Are you guys ready? Okay. So, for example, for the polynomial, all right. So A, find all possible rational zeros. B, find all the real zeros. C, write P of X in terms of its factor. Its factor. Linear factor, I should say. Of its linear factors. Okay? All right. So this is my first one. So f of x, oh, not f of x, p of x, I'm sorry. Because I was using p. So p of x is 2x cubed plus x squared minus 13x plus 6. All right. So A. Okay. So A. What are the potential rational zeros or possible rational zeros? Yeah, so what is it? How do I answer this? Plus or minus P or Q, okay. So plus or minus, what are P? 1, 2, 3, 6. What are Q's? 1, that's it? 2, okay, good. So if I have to list this, what is in my list? So you have to list it. Plus or minus what? 1, 1, 2, 3, 6, right? So this is when I use denominator equals to 1. Now, what is it when I use denominator 2? 1/2, and then 2 over 2. We already wrote 2 over 2, which is 1. And then what else? 3 over 2. That's it. 6 over 2 is 3. We already wrote 3, didn't we? Okay, so I have, let me see, 1, 2, 3, 4, 5, 6. Plus and minus, so 12 potential rational zeros. Don't I? So I have 12 potential rational zeros. So I have 1, 2, 3, 4, 5, 6, but I have to plus or minus. So which one of these are real zeros? So then you have to do trial and error here. So real zeros. Let's see. Let's see if does 1 work? What is P of 1? So you got to do trial and error here. Does 1 work? So 2 plus 1 minus 13 plus 6. No, 1 doesn't work, right? You know off the bat it doesn't work. How about negative 1? Does negative 1 work? So negative 2 plus 1 plus 13. Oh, no, it doesn't work. Then you're going to try P of 2. Does P of 2 work? Let's see. This one I probably have to write down. So 2 times 2 cubed plus 2 squared minus 13 times 2 plus 6. So does 2 work? Is it equal to 0? Let me see. So 16 plus 4, 20 minus 26 plus 6. Oh yeah, this is equal to 0. Yes. Yes. Oh, I'm going to do it next. Yeah. Yes. So once I find a 0, then I'm going to teach it that way. Yeah. So now, once I find a 0, how do I find the others? Look at these. I have a cube, right? And I found 1 0. What is the first 0 that I found? 2. How many other zeros do you think I will have? 2 more, right? So if it is a cube, it has 3 total zeros. They can be complex, can be real. So, but if you have a cube, you have 3 zeros. But some of them can be complex. Yeah. Now I find 1. So what I could do is do synthetic division using this as a 0. So to find the others. So how am I going to do it? Well, this is my 0. 2 is my 0. What am I going to put here? As dividend. So 2, 1, negative 13, 6. All right, so this is how I'm going to find my other zeros. Can you do trial and error? Yes, you can, but they may not be rational. They may be complex. So once you find 1 for cube or 2 for 4th power, then you could do synthetic. Yeah. So now bring down the 2. Then what? What am I supposed to write here? 2 times 2, which is 4. And then we add this 5. What am I supposed to have right here? 5 times 2, which is 10. So this is negative 3. I was going to write negative 13. No, negative 3. So this is negative 6 and 0. So you see that the remainder is 0. Why? Because 2 is 0, meaning the remainder must be 0. All right. Good. Yeah. Now I'm going to rewrite the zeros. Rewrite f of x as the product of its factors, but this is not linear. So f of x is equal to, how do I write these zeros as the factor? What am I supposed to write here if this is my 0? X minus 2. And then, what about this? 2x squared plus 5x minus 3. All right. Yay or nay? Yay? Okay. So what is this 2x squared plus 5x minus 3? Oh, that thing you guys know, right? So we have constant, coefficient of x squared, coefficient of x cubed, x to the 4, etc. So you start with remainder here, and then constant x squared, etc. Now, is this factorable? Negative 6 and positive 5. Is it factorable? Yes. So, wait, the product is negative 6? Yes. So how do you factor this? Yes. So I'm going to use my AC method. 2x. So you see it's really handy, the AC method, divided by 2. Or you could use trial and error. As long as you could do it, I don't care what method you use to factor. Yeah? But I'm using the AC method here. This is how I set up. I hope you remember, right? Okay. So if my AC method, the product must equal to -6. The sum must equal to 5. Okay. So what are the two numbers? 6 and -1? Okay. So +6, -1. Now, what am I going to do with my 2? You split it up into what? 2 times 1. Okay. All right. So f of x is x minus 2. What about these? 2x plus 6 divided by 2. What is 2x plus 6 divided by 2? X plus 3 times 2x minus 1. Right? Okay. So, this is your answer to C. So I was doing the C first. I haven't answered my B. This is f of x. Oh, why did I put f of x? I used P, didn't I? Let me use P. I'm sorry. I need to be consistent here. Okay. So this is my answer to C. I haven't answered B, but I will in the next line. So if we say write P of x in terms of its linear factors, this is my answer. This is P of x written in terms of its linear factors. Now, this is my answer to B. What are the zeros? Now here, let's start with this. 2, -3. What about these? Half. That's it. This is my answer to B. How do you get half? So you set everything equal to 0, right? So x minus 2 equals 0, x equals 2. X plus 3 equals 0, x equals -3. 2x minus 1 equals 0, x is equal to half. Yay or nay? So let's do another one. All right. Okay. Let's see. All right. Factor completely. Okay. All right. So the next one is x to the 4th. Let me see. So number 2. So this is a little bit more, and then maybe we need to try a little more. So P of x is equal to x to the 4th minus 5x cubed minus 5x squared plus 23x plus 10. All right. So x to the 4th minus 5x cubed minus 5x squared plus 23x plus 10. So, A, what are the candidates for rational zeros? So I have to write down potential rational zeros. All right, so what are they? Plus or minus P over Q, which is plus or minus. P is what? 1, 2, 5, 10. Okay. So we have only, well, not only, we have 8 values. 1, 2, 5, 10. All right. So which one of these is real zero? So you gotta do trial and error. What about P of 1? Is it 0? Let's see. So it's 1 minus 5 minus 5 plus 23 plus 10. It doesn't look like it's 0, isn't it? Okay. How about P of -1? So -1, no, 1 plus 5 minus 5. Okay, so 1 plus 5 minus 5 minus 23 plus 10. Is this 0? No. How about 2? So here you have to try a few. So 2 to the 4th minus 5 times 2 cubed minus 5 times 2 squared plus 23 times 2 plus 10. Let me see. This is more positive than negative, is it? So this is not 0, right? Okay. Wait, I mean, you guys have to calculate. How about P of negative 2? Would it work? Okay, I'm going to wait for you. Because you're supposed to calculate these, not me. Is P of negative 2 equal to 0? Is it? So, negative 2 to the 4th minus 5 times negative 2 cubed minus 5 times negative 2 squared plus 20 times negative 2 plus 10. Is it? Oh, okay, so you guys confirm this is a 0? Alright, so this is 0. Okay, I didn't calculate it. Okay, but so after I find a 0, what do I do? Synthetic? Actually, here we have to find one more because this is x to the 4th. Yeah, but yeah, we could do synthetic now. So B, so we're trying to find real zeros. So I'm going to do synthetic. All right, so this is, what do we call this? 1. Oh, so this is negative 2. So 1, negative 5, negative 5, 23, 10. All right. Okay. So bring down the 1. 1 times negative 2, negative 2. So negative 7. Is it? 14. 9. Negative 18. 5. Negative 10. 0. Okay? All right. Good. Now what do we do once we write this? Any idea?
X plus 2.
Yes. So we write P of x as equal to x plus 2 times x cubed minus 7x squared plus 9x plus 5. Okay. Can you factor this? No, right? So you sort of have to do it again. Do you see? So this is called, I'm going to call this Q of x, which is a reduced polynomial. All right. So this is the reduced polynomial, but can you factor it at this point? No. So what do we need to do? We need to do the other thing again. Yes, right, for this polynomial. So let's see, does Q of 1 work? How about Q of 2? Q of 1 doesn't work, does it? So then we do, maybe we try with the, how about Q of negative 2? Does Q of negative 2 work? So we will try whatever we haven't tried before. Okay? If we cannot find it, then we have to go back.
We have to plug the rational zeros back into the new format we just made? The new,
So we need to plug in the rational zeros. Yes. So this is 5 though. Right? So 5, what are the possible rational zeros? 1 and 5. Oh, so the 2 wouldn't work, right? We don't have to try 2. Why would I try 2? That was your question, right? So does 1 work? Or let's try the 5, because we haven't tried the 5. Right? So let's try the 5. Does the 5 work? From the new equation. Yes. So our goal, our job right now is reduce to factor in this part. Right? So that's why we don't have to worry about the beginning, the polynomial in the beginning. Our job now is reduce to factoring this part. So Q of 5 works? Oh, it's equal to 0? So you guys calculate? Okay, then I just put 0 here, okay? All right. So what am I doing now after I found Q of 5 is 0? You do what? Sympathetic again, okay? Using 5, and what am I going to put Q or P here? Q, which is 1, -7, 9, 5. Yes. My job for P of X is done. So now what I need to do is Q of X. I need to factor this. So then my rational zeros will be, when I'm trying it out, I'm only using the rational zeros for my Q of X. So that's why it's only plus or minus 1 and plus or minus 5. Well, this is only 1 and 5. Plus or minus 1 and plus or minus 5, and I don't have to choose -2. Why? Because -2 is not a potential rational zeros from the 5. Because I only have 5. Yes, I only look at the new Q of X. Why? Because now my job is switched. I need to factor out this one instead of the big original one, x to the 4th. Yeah. So I'm looking at the reduced polynomial. Yeah? Okay, good. So now here, what do we do now here? 1 times 5, 5, -2, -10, -1, -5, 0. All right. Yes?
Okay, so now that we've gotten this far, do you have to bring x plus 2 down?
X, yes, I do. Because my original polynomial is this. So this is what I'm going to do next. I'm going to write P of X. P of X is x plus 2, okay, and then x minus 5 times x squared minus 2x minus 1. All right. Okay. Is it clear what we're doing? So we're switching a little bit. So it's like it's like you're dividing your task, and then at the end you combine them together. Does that make sense? So just say I want to make a common final for Math 260. So some people will be working on chapter 1 and 2. Some people will be working on chapter 3 and 4. Some people will be working for chapter 5 and 6, right? So this is when we're doing with the reduced test. So I'm only working on chapter 1 and 2. And then what happens at the end? We combine them. Does that make sense? Okay, so this is where we combine them. Yeah. Now, I'm not done. I have to find the real zeros. And I don't think this is factorable, is it? Okay, so what would you do? So I know the zeros from here. This is -2. The zeros from here is 5. And what about here? You have to complete the squares or quadratic formula. So if I want to find the zeros, then I have to do this. X squared minus 2x minus 1 is equal to 0 because it's not factorable. So I have to solve it. What would you do? Complete the square? Oh, you want to complete the square? Okay. Is equal to 1. What am I adding? Yes, you add 1 both sides. All right. So this is x minus 1 square is equal to 2. Yes. So then what? Square root both sides. And we do have plus or minus. Okay. Plus or minus. Okay. So what is my x? So x is equal to plus or minus square root of 2. X minus 1, right? So x is 1 plus or minus square root of 2. All right. So do I know all my zeros now? Okay. I have to wait for you. And then I want to write the zeros. Okay. Finish? No? Go to the next page. So what are my zeros? -2, +5, 1 plus square root of 2. Okay, how many of them? Okay, good. So I will scroll down. Yes? Yeah, okay. Maybe I'll leave it here a little bit. Oh, okay. So zeros is -2, +5, 1 plus square root of 2, 1 minus square root of 2. So this is the answer to B. So this is my answer to B question. Find all the zeros. So these are all my zeros. Now, how do I write it in terms of its factors? Yeah. Oh, okay. So how do I write this in terms of its linear factors? So P of x is equal to what? X plus 2, x minus 5, x minus 1 plus square root of 2. Remember, 1 plus square root of 2 is in parentheses. And then the last one, x minus, parentheses, 1 minus square root of 2. All right. So this is x plus 2, x minus 5, x minus 1 minus square root of 2, x minus 1 plus square root of 2. That's it. Yes? Okay. Yeah. Yes, Sandra. You could just skip down to the bottom version. Yeah. So this is your answer to C. And you're done. So if you have cube, how many potential zeros do you have to find? 1. Oh, yeah, you have 3, but you know you have 1 and then you do synthetic, right? So if you have 4 power, most likely how many do you have to find? 1 first, and then you have a reduce, and then find another one, right? Because we don't know how to deal with cube. We know how to deal with, for example, if I have this, I know how to deal with this, right? We could use the quadratic formula or completing the square. What about if x cubed? I don't know how to do it. That's why I need to find the potential zeros. Are we okay so far? So far, so good? All right. Let's see. The next one is the cart rule of signs. Ready? So this is new, right? We haven't done it in the previous classes. So this is new stuff. Chapter 3 is pretty much new. Oh, you're not done? You're not done? Oh, finish? Okay. So B is the cart rule of signs. The cart rule of signs. Is that important? So yeah. What does it say? It just says what's the number of positive real zeros, so, and the number of negative real zeros. Okay. So let P be a polynomial with real coefficients. All right. Okay. All right. So the way the book writes it, it's a little bit difficult, but this is how I'm going to write it. So the number of positive real zeros, so we're talking about positive real zeros, so positive, is the number of variations of signs in f of x. Okay, so we're talking about positive is f of x. The number of variation of signs in f of x. And then the book says, or is less than that by an even whole number. But I'm just going to write this instead of writing or is less than that by an even whole numbers. So I'm just going to say keep subtracting by 2. By 2 until reaching 1 or 0. Okay, I think that's really easier to understand than or is less than that by an even whole number. Now, the next one is the number of negative real zeros. So a negative real zero is the number of variations of signs in f of negative x. So if we're talking about negative real zeros, we're talking about f of negative x. And then I'm also going to keep subtracting by 2 until I reach 1 or 0. So I'm going to copy this. Copy. Paste. Oh, okay. Good. Let's put this up a little bit. Oh, until reaching 1 or 0. That's what I want to do. I don't know. All right, and then let me erase this. Okay. So, is this important? So, not really. Yeah. Basically, what you do is you can use it sometimes with when you test the potential rational zeros. So you can choose the which rational zeros you want to test. So instead of doing 1, -1, 2, -2, maybe you can see, oh, these are probably it's more positive zeros more than negative, so you try the positive ones. Okay. So for example, use the cart rule of sign to find the number of positive and negative real zeros. All right. So, number 1. P of x is 2x to the 5th plus 5x to the 4th minus 8x cubed minus 6x plus 9. So we don't care if the terms skip. It doesn't matter. Yeah. So we don't care if the terms skip. Okay. So here I'm missing x squared. So we don't care if it's missing x squared or not. Yeah. So the number of positive real zeros. So what would you do? So we're going to count the variation of signs, right? Okay. So what about these? This is positive, this is negative. So what do we have here? 1. Oh, let me do something like this. So this is positive, this is negative, so 1. What else? Okay, so that's 2. Okay, so the number of positive real zero is 2. And then what do I need to do? What about this? Keep subtracting? Yeah, so you subtract by 2 or 0. So you might have two positive real zeros or non-real zeros. Yeah, so I'm just going to subtract by 2 until I reach 0. Can I subtract by 2 more? No. -2, right? I mean, how can I say the number of real zeros is -2? You can't have that. All right, now B. The number of negative real zeros. So in this case, what am I looking at? Am I looking at P of X? No, I'm looking at P of negative X. Okay, so what is P of negative X? Negative 2x to the 5th. So basically what we did was, what did I just do? Sorry. So basically what we just did was 2 times negative x to the 5th, right? Plus 5 times negative x to the 4th, minus 8 times negative x cubed, minus 6 times negative x, plus 9. Right? Okay. Now, which signs would change? The one with the odd exponent. So this one will be negative 2x to the 5th. What about the x to the 4th? Well, it's going to stay the same. Right? How about the x cubed? Plus 8x cubed. And then what about the 6x? Plus 6x plus 9. Oh, they're all plus. Okay. So how many variations of signs? Only one. Oh, so this one only. So how many number of negative real zeros? 1. 1 only. Yeah? Okay. Good. So 1 only. Okay? All right. Are we okay so far? Yes? Okay. Now, let's see, we have 5 minutes, so let's do upper and lower bounds theorem. Yeah. Are we ready? Okay. So we have only one. This plus 9 is belongs to the top. And then I wrote the plus 9 again. So only 1. Because I cannot subtract 1 subtract by 2. What about if I have 5? How will I answer it? What about if I have 5 variations of sign? Then it's going to be what? 5 or 3 or 1. What about if I have 6? 6 or 4 or 2 or 0. Does that make sense? So you just keep subtracting by 2. Yeah? Okay. Yes?
So, I'm sorry. Okay, so A, the number of real positive real zeros is 2 or 0. Is that a total of 2 or is it the number 2?
No, it's a total of 2 or a total of 0.
Okay.
Yeah, so it's not the number 2. It doesn't give you what the solution is. It just tells you how many.
Okay.
Yeah. So for negative, you're doing P of negative x. Okay? So are we okay? Okay, so let me finish the lower bounds and then we're done. So I probably will go over a little bit. Okay, I'll let you guys go earlier on Monday. How about that? So I borrow your time now. Okay, maybe 5 minutes. So upper and lower bounds theorem. Okay, so let P be a polynomial with real coefficients. All right. Now, so if we divide P of x by x minus b using syntactic division, and in this case, where b is greater than 0 using syntactic division, And if the bottom row has no negative entries, then B is an upper bound for real zero. Meaning B is the greatest zero. You cannot find any other zeros greater than B. So B is an upper bound. So B must be positive. Yeah, and the bottom row, no negative entry. Now, number 2. So if we divide P of x by x minus a, and in this case, a is less than 0. Okay. Using synthetic division. So using synthetic division, and if the bottom row has entries that have alternate sign. What do I mean by alternate sign? So plus, minus, plus, minus, plus, minus, or minus, plus, minus, plus, okay? Then A is a lower bound for the real zeros of P. Alright? Alright. So what about the 0? Well, if you need positive, you can consider 0 as positive. Yeah, if you need negative, you could consider 0 as negative. Yeah? So we're talking about A is less than 0. Bottom row has entries that have alternate signs. Lower bound. A is the lower bound. Right? Can I do one example before you guys go? I know it's 8:50. That's fine. Yeah, but it's just next door, isn't it?
No, I'm on the opposite end.
Oh, okay, okay. Well, so for example, show that A and B are lower and upper bound. So this is your P of x, which is x to the 4 minus 2x cubed minus 9x squared plus 2x plus 8. And A is negative 3 and B is 5. So do we want to show the lower bound first or the upper bound? Upper first? So we're using the B, right? The positive one. Okay. So what are you going to do? Synthetic division. Okay. So, and then using B. So 5. So 1, negative 2, negative 9, 2, 8. Okay? And I'm not missing anything. And then you know how to do synthetic here, right? So let me just do it fast. So 1 times 5, 5. 3, 15, 6, 30, 32. What is 32 times 5? 160? 168. Did I do it right? So what do you see on the bottom row? They're all positive. So what is your conclusion? So since the bottom row contains no negative entries, 5 is an upper bound. Okay? Okay. So this is A, upper bound. How do you show that negative 3 is a lower bound? What would you do? The same thing. So, but you're still writing, aren't you? So do the same thing for the lower bound. So I have to use a different page. That's why I'm waiting for you. So they're all positive. No negative entries. No negative entries. All right. Can I do the next page? Yes? Okay. So B, lower bound. So we're checking if negative 3 is the lower bound, right? So we do sympathetic again. So what is it? Was it 1, negative 2, negative 9, 2, 8, and then this is negative 3? All right. So 1 times negative 3, negative 3, negative 5, this is 15, 6, negative 18, negative 16, 48, 56. Do they have alternate signs? Yes. So since the bottom row have alternate signs, so it has to be alternate, okay? Signs. Negative 3 is a lower bound. Okay. So it is have to absolutely be alternate. So you can't skip. So if you have 1, negative 5, negative 6, then for that doesn't work. All right. Okay, so I am actually done. Yeah, hold on. I'm actually done with 3.3, so you could actually do the homework. Yes, can I answer the question? Oh, it's given. Yeah. So this is given as the problem. Yeah, so it's given. It's part of the problem. So this is what happens. Sometimes it's from the list of your rational zeros. Yeah. So I mean, if you know that negative 3 is a lower bound, would you try negative 5 when you try to find the rational zero? You won't, right? So if you know that 5 here is an upper bound, would you try 8? You will not substitute 8. Does that make sense? Yeah. Yeah, so you wouldn't just say for sure 8 will not be a 0 because 5 is the maximum. 4 maybe, but 8 will not. Yeah, so that's how it is used. Useful, probably not too useful, but it's good to know. Yeah. Okay, do you guys want me to scroll down? The upper bound is the maximum? Yes. So the zeros cannot be more than 5. You know how the potential rational zero is plus or minus 1, 2, 4, 8? Yes. So you're not going to try 8 once you know that 5 is an upper bound. Okay. That's the use, but you know it's less useful. I mean, it's not that useful. Yeah.
I was just going to show you that I did have 2.5.
Yes, you told me yesterday.
Okay.
Let me see.
Because you were like, oh, show me tomorrow.
Yeah, I will. I remember. Okay, let me stop the recording. Are you guys okay? Stop the recording? Okay, let me stop it. So I will see you on Monday, okay? And we're done with 3.3, real zeros of polynomial. We could review, but we're done with 3.3.